Welcome to Bit2Net Code channel. Guys, in today's session we'll see the different kind of OSPF router types and how do we do redistribution. Okay, so let me explain you about the uh, environment we have here. So here have we have five routers R1, R2, R3, R4 and R5. Okay, and here we have backbone area 0 in which we have three routers R1, R2 and R3. Okay, and then we have a regular area that has R1 interface and R4 interfaces. And then we have EIGRP protocol running on R3 uh, router and on R5 router. Okay, and EIGRP process ID will use autonomous system number EIGRP 100. And for OSPF, this is locally significant, so we'll use OSPF process ID as per the router number. Okay, and the IP address scheme that we are using, you can see as usual, the network between R1 and R4 will be 14.1.1, R1 and R2 will be 12.1.1, R2 and R3 will be 23, and R3 and R5 will be 35, right? So let's start the routers. IP addresses are already configured. So and we will take console session now. Okay, R1, let me open R2, R3, R4 and R5. So I have not configured any protocol on these routers. I have only configured IP addresses. Let me show you IP addresses first of all. Show IP interface brief, exclude unassigned, right? IP addresses are up. R1 and there is no routing protocol running. Let me show you. Show IP protocols, no protocol. Show IP int brief unassigned. Show IP protocol. Let's check on R3 also. Show IP int brief exclude unassigned. Show IP protocol. Show IP int brief exclude unassigned. Show IP protocol, and on R5 also. Show IP int brief exclude unassigned. Show IP protocol. Okay, now we will configure routing protocols OSPF and EIGRP on the all the on the routers, right? We'll run OSPF on R1, R2, R3 and R4 and EIGRP on R3 and R5. So let's quickly run OSPF config T on R1 router OSPF 1 network. On R1 we will be configuring 114.1.1.0, 0.0.0.255 and 14 network will be in area 1. Okay, and uh, 12 network will be in area 0. And also give a router ID 1.1.1.1. Okay, and end it. Right. Now let's go on R2. On R2, all interfaces of R2 are in area 0, so we can use a shortcut router OSPF 2 router ID 2.2.2.2 network 0.0.0.0 0.0.0.0 area will be 0, right? And right. So now we should get the message about the neighborship. Okay, we got that message, and here also we have the loading done. Now let's go on R3. R3, one interface is in area 0 and other is in EIGRP. Config T router OSPF 3 network 23.1.1.0 0.0.0.255 area 0 router ID 3.3.3.3 and right. Okay, and we also have to configure EIGRP on R3. So let's do that also. Router EIGRP 100. Network will be here. Network we are using 35.1.1.0. Okay, wildcard mask 0.0.0.255 and right and right. Show IP OSPF neighbor. Okay, for OSPF neighborship has been created. Now let's go to R4. Let's write it. Now let's go to R4. R4 is completely in area 1. Config T router OSPF 4 network 14.1.1.0.0.0.255 area 1 router ID 4.4.4.4. Okay, let's clear IPOSPF because this command should be router ID command should be run before giving the network command. So let's reset the OSPF process so that a router can pick the new router ID that we have given. Show IP OSPF neighbor. Let's wait. Neighborship is in the process. Show IP protocol. We can see that it is routing for this network. Okay, area 1 14 dot show IP OSPF neighbors. Neighborship is created, but it is in two-way state, right? Let's check on R1 what is the status. Okay, loading done, and here also loading done. Show IP OSPF neighbor again. Now the full loading has been done, and R1 is the DR, right? Now let's go to R5. On R5 we are running only EIGRP. Config T router EIGRP 100 network. Our network is 35.1.1 35.1.1.0.0.0.255. Enter. Okay, so adjacency has been created. Show IP EIGRP topology. Show IP EIGRP neighbors. Okay, neighborship is up. Show IP route. Now because we have two different protocols running on R3, right? As long as we do not do redistribution, routes will not be shared. Now let's go on OSPF routers and see the kind of routers we see in our OSPF domain. Show IP OSPF database. So in OSPF we have four kind of routers. First of all, we have a router that is completely in area 0. That is called internal router. Okay, and the router that connects other OSPF areas to area 0. those are called area border routers. So here R1 is a area border router, R4 is a internal router, R2 is also internal router. Here R3 is a autonomous system border router because ASBR, because R3 is connecting two different protocols, OSPF and EIGRP. So any router that is in both EIGRP and OSPF, I mean two different protocols, that router will be called as autonomous system border router, and this is also internal router for EIGRP. So these are the different kinds of routers, and let's see what kind of information, what kind of LSA packets they generate. So here we see that here a router, OSPF router with a router ID 1.1.1, process ID 1, a router link state area 0. Okay, so first is a router LSA, and second is this is LSA 1. Second is a network LSA that is generated by LSA 2, that is generated by a DR. Then is LSA 3, that is generated by area border router. Okay, and then we have a summary network LSA uh, that is generated by area border router. So here we have uh, mm, summary network LSA summary router generated by for area 0 and for area 1. So they are being generated by router with advertising ID 1.1.1, right? Here we can see that 1.1.1 is generating the summary for this network and this network, because it is area border router. Area border router will generate the summary LSA, and all other routers will generate the LSA 1 1, right? Mm, and LSA 2 will be generated by LSA 2 is the network LSA that will be generated on a broadcast network by DR, whosoever is DR. Okay, now let's see, though we should not have end-to-end connectivity at this time, because EIGRP will not, this router R3 will not do redistribution. We haven't configured yet. So we have a route on R1, route for 23, 12 and 14, right? 23, 12 and 14. So OSPF routes are being shared, but EIGRP routes are not being shared. Let's do here also. Okay, here we are getting inter-area route also, uh, that is coming from 12.1.1, 12.1.1, right? This router is sharing inter-area routes, because these three routers and these two routers are in different areas, so interfaces are in different areas. So area border router is sharing the inter-area routes. Now let's go on R3, show IP route. Okay, OSPF routes are coming, inter-area routes are coming. Now here we will not have much routes. We have only inter-area routes and connected routes. R4. R4 is here. Okay, and R3 is this. And it is showing this 35 network as connected route. Right, 35 is connected, 23 is connected. And a 12 network, it is learning from OSPF. Okay, and 14 network, this network, it is learning from OSPF as inter area, right? Because OSPF is running on R3 also. So now let's go on R5. R5 is the uh, router on which we don't have much routes because we have not configured routing. So now what we will do, we will configure redistribution on R5. After that we should have end-to-end connectivity. So first of all we will go into router EIGRP 100 redistribute OSPF. Now let's see R5. No, we will not do redistribution on R5. We will do redistribution on R4, not on R4, I'm sorry, R3, because R3 is the ASBR. This router is the ASBR, so redistribution will happen here. It will transfer EIGRP routes to OSPF domain and OSPF routes, all these routes and these routes into EIGRP. So we have to do redistribution on R3. Config T router EIGRP 100. Okay, we will first of all we will inform to EIGRP to transfer OSPF route. Distribute OSPF. Let's see what is the OSPF process running here. It should be 3. Okay, now the important thing to note down is here that OSPF does not use metrics. OSPF use cost only for calculation of routes, whereas EIGRP use metrics. So we have to give metrics of OSPF that this R3 will send to EIGRP domain. So metrics will be using first is bandwidth. Okay, so for bandwidth, let's give the bandwidth we have to give in kilobits per second. So first fast Ethernet we can in 10,000 kilobits per second. Next metric is delay in a microsecond, in tens of microsecond. So let's give it 100 microsecond. And then reliability, here reliability is 255 is 100% reliable, so let's make it 100% reliable. And EIGRP effective band metric loading, where 255 is 100% loaded, so let's give it 100%. And EIGRP MTU maximum transmission unit, for we should keep it 1544, that is the default. Any MTU size bigger than 1500 will be discarded by the routers, right? So let's give it 1500. Okay, after that, if we want to do any kind of filtering, also we can use further options, but for now we can end it here, right? And now we have to go into uh, OSPF 3, and we have to, I'm sorry, router OSPF 3 redistribute EIGRP autonomous system that we are using is 100. EIGRP 100. Now if I put enter here, right, let's see what will happen. It will say only classful networks will be redistributed, but because EIGRP and OSPF support a classless network, so we have to use subnets command so that all the classless networks are redistributed, right? So if we want, we can also use a metric type. By default metric type to external is used if we don't give the metric type, right? So we will check this later on, let's not give it right now. And right now let's go to R5. The redistribution has been done, and now let's see routing routes if they have been exchanged. Okay, so we see that with the help of a EIGRP, external routes has come from OSPF. Okay, here D and EX says a EIGRP external. Okay, these are the EIGRP external routes. Okay, and this is the internal route or EI connected route or EIGRP route, but this is the external route. Let's go on R2 also, show IP route. Here we see that uh, OE2, right? This is the E2 is the metric type I just told you. By default, metric type E2 is transferred. Let's see what is the E2. Here we have OSPF external type 2, right? External type 2 does not add the internal cost. We will shortly discuss that also. Show IP route. So inter area routes. Show IP routes. E2 routes. Show IP route. Now we can see that external routes are coming on all the routers. So let's try to ping end to end 35.1.1.5. I think it was the R5 35 1.1.5. So let's try to ping this, and this is working. So if I try to ping 35 1.1.3, that should also work. Okay, now we have end-to-end connectivity because we have successfully redistributed EIGRP and OSPF. So let's try to ping a 14 network. 14.1.1.1. Okay, and 4. So this way we can see that we have end-to-end connectivity. Now uh, let me show you a few more interesting show IP EIGRP topology. And as we know that EIGRP uses a feasible distance and a reported distance, right? Successor and feasible successor concept. So we have already given metrics. So here we can see that these are uh, uh, the metrics of FD values that are calculated by R5, right? And R5 has received uh, reported distance 281600 from R3 to reach 12 network, 14 network, 23 network, and 35. For all, it is the same, right? So R5 has received these values from R3. Now, what is the value on R3? Let's just see that also. Show IP EIGRP topology. See here the values are 0 because these are the reported values, right? So because R3 is not receiving these values because OSPF does not understand these metrics. So R3 has created these values. Okay, so it has only FD value. It has 0 for reported distance. So it has calculated these values depend with the formula that we discussed in EIGRP session, that is 10 power 7 divided by minimum bandwidth into delay by cumulative delay by 10 into 256. So that is the formula that EIGRP uses to calculate the feasible distance. So for Ethernet, it has calculated this value for all the routes, right? Because EIGRP doesn't know anything beyond this interface. And let's show IP OSPF database also. Show IP OSPF interface F0 F0/0 Here we can see that it uses cost, right? Show IP OSPF. Let's see neighbor, fast Ethernet. We are on R3. Let's see for F0/0. Okay, and let's see same thing. Show IP OSPF database. Show IP OSPF neighbors. Show IP OSPF interface. R2 0/1 0/1. See, it is using cost 10, right? Now the interesting thing to note here is that uh, this is ASBR. So let's use this command on R3. So actually one thing that I wanted to show you, uh, here we have R1 as ABR, right? Show IP OSPF, show IP route OSPF. Okay, so it is using the cost as 20, right? And what is this cost? This is for E2 routes, right? For E2 R1 is towards this hand side. R1 is using the seed metric, that is the default cost for external routes, that it is using for as 20. And let's check same thing on R3 also. Show IP route OSP. Here we can see that here also it is getting the default route 12110 as a 20, right, via 23112. So that means ABR, whenever ABR sends the route to other protocols, it does not add the internal cost. Here also the cost was 20, and on R3 also the cost is 20, right? But for inter area, so it adds the cost, right? You can see that for area 1 it has added the cost of fast ethernet network. For every fast ethernet network 10 cost will be added, and 20 is the default for one default seed metric. So this seed metric is generated by ABR for inter area routes and for external routes. For inter-area routes, uh, for external routes, the cost is not added, whereas for inter-area routes, it is added. So on here on R5, show IP route, we see that it has external routes that only EIGRP understands, and 170 is the AD value for EIGRP external. Right, all these are the external routes. So EIGRP AD value is 170, and for internal routes EIGRP value is 170 AD value. So guys, this was the short video about router types in OSPF, and how do we do redistribution of OSPF and EIGRP routes. If you like this video, please hit on like button and subscribe to the channel. Thank you for watching this video.